Thank you, Dave, and it's a real pleasure to be able to introduce today's speaker and a long-term colleague, Dr. John Cherry. John did his bachelor's degree at the University of Saskatchewan, getting a bachelor's in geological engineering. From there, he went to California and did a master's in geological engineering. And on leaving California, he went to Illinois. And yeah, you can wonder about someone's wisdom in leaving California for central Illinois. But anyway, he registered in a PhD program in geology with a specialization in hydrogeology. And as fate would have it, Bob Vervolden was a lecturer at the University of Illinois and was John's supervisor. And when John completed his degree at Illinois, he accepted a NATO NRC postdoc fellowship to go to Bordeaux for 1 year. And following that year, he returned to Canada and took a position at the University of Manitoba, a faculty position. And things seemed to go well at the University of Manitoba, although he stayed for only 4 years. And that always seemed a little bit curious to me. But then I discovered that while he was in the initial years at the University of Manitoba, Bob Vervolden accepted a position as chair of the department at the University of Waterloo. And he was not only chair of the department, but he had a mandate to develop a program in environmental geology and particularly in groundwater. So it became clear that Bob Vervolden probably bent the ear of John Cherry and convinced him how wonderful his life could be in southern Ontario. And so John moved to Waterloo in 1971. So in the early 1970s, groundwater contamination was not on the priority list of contaminants or environmental problems. Funding agencies, research groups were paying relatively little attention. So it was rather surprising when John, shortly after John arrived, that he declared he was going to commit his research program to groundwater contamination and remediation. So over the next few years, he conducted a number of studies, some dealing with nitrate in groundwater, other agricultural chemicals in groundwater, landfill leachate, migration of radioactive materials, migration of contaminants from mine tailings, and a host of others. And most notably, and the area for which he is perhaps best known, he was one of the earliest to recognize the occurrence and the risk and the fate of chlorinated organic contaminants in groundwater, and certainly led that field for many years and maybe still. In addition to his work with various individual contaminants, in his research program, John helped to develop and test various instruments for groundwater monitoring and contaminant migration studies. He also played a big role in understanding the interaction between geologic materials and contaminants. So the disposal of hazardous waste in thick clay deposits, for example, is one of the areas where John and his team made major contributions. Although the groundwater contamination was a minor topic of interest in the early 70s, by the late 80s, early 90s, it had become a major topic, and certainly in part through the work of John and the group at Waterloo. So by the early 1990s, groundwater contamination was a major subtopic within the field of hydrogeology, and there were in fact journals on the topic. And largely through the leadership of John Cherry, the group at Waterloo had established an international reputation for contaminant hydrogeology. In addition to his early work in contaminant hydrogeology, John received most of the major awards that were made available to hydrogeologists. And I'll just mention two of them. One is the Lee Kuan Yew Award, Water Prize, and the other one is the Stockholm Water Prize. And as many of you know, the Stockholm Prize is really at the very peak of the mountain, and is quite often referred to as the Nobel Prize for water research. So having introduced those two awards, there seems little left to be said, and so I'd like to call on John Cherry to deliver his address.
Thanks, Bob, and thank you for coming to this talk on this unusual topic. It's a great pleasure to be back at the University of Waterloo and giving a lecture to so many people that I've known from the past, former students and colleagues and whatnot. So Bob mentioned that I was at the University of Manitoba, and then Bob Verbolden offered me a position to come to Waterloo, and I was from the prairies and was quite content to stay in Manitoba. So I turned him down for the first time. But then he offered me the position again, and it rescued me from my stupidity. And so I think in many cases in my career, I've been rescued from my stupidity by having a second chance and having good colleagues. So I arrived at the University of Waterloo at a time when it was booming and expanding, and the enthusiasm was unbelievable relative to other universities at that time. And all of a sudden, I had amazing colleagues, the people that Bob Verbolden hired, Emil Friend, for example, an amazing human being, and Bob Gillum. And so what I found was that it wasn't difficult to be very successful and become known while working out of the University of Waterloo, because the opportunities were so great and the colleagues were so wonderful and the enthusiasm was so superb. And then that led me then to receive, these various awards. And so, for example, how do you get to receive the Lee Kuan Yew Water Prize and the Stockholm Water Prize? Well, the criteria are pretty straightforward. First of all, you have to have a very heavy resume, and it doesn't really matter much what it's got in it. It's got to be heavy. And to have a heavy resume, you have to be very elderly. And that's a problem. And in fact, if I were running the show, I wouldn't allow these big awards to be given out to people that are so elderly, because it doesn't do them any good, in a career sense, and it basically only causes stress. So I arrived in Singapore, after 20 hours on an airplane, which is an accomplishment in its own right. So not only do you need to be elderly, but you have to be still able to get on an airplane and function. So I arrived, and nobody was interested in trichloroethylene or any of these things that I'd built my career on. And they had many media interviews lined up with CNN Asia and whatnot, and newspapers, etc. And what I was typically asked was like, what is groundwater and why is it important? And for which I had no good answer at the time. I fumbled my way through it. So here's the title of this talk, and a secondary title could be this title here. The title changes from wherever I give the talk. And so I was asked in Singapore, is groundwater important, and if so, how and why is it important? So I've spent then the last 5 or 6 years trying to figure out a good answer to this question, and this lecture is the end result of all of this striving to get an answer to the question. Or another way of putting it is, what is the state of humanity and the planet? And I'm not presenting anything that's original here. I'm just connecting the dots of information that's already available. So we've got some groundwater key facts. 99% of all liquid freshwater is groundwater, and I didn't know this until 2 or 3 years ago, and it's a very important number. So all this river water and lake water and wetland water and whatnot and so forth, groundwater really is the key to it all. About half of humanity drinks groundwater. Most of surface water has groundwater origins, and groundwater supports many ecological systems. So I shouldn't really be having to give this talk. Everybody should know this, but the fact of the matter is people are totally unaware of groundwater outside of the groundwater community. So what is the state of humanity and the planet? Really, that's what this lecture is all about, and that's what my journey has been all about here. And so what I'm doing is not developing original information, but I'm trying to connect the dots from information that's already out there. Oops, what do I do here? Okay. So in my era, my formative years in university and then as a young professor within the 1960s, and of course at any era in the state of humanity, you have to have something big to be afraid of. So in that era, we were afraid of exponential population growth and nuclear war. And we were wondering, if we would survive that era. And then there was this report by the Club of Rome, a very, very high-profile report done by a bunch of eminent computer people at MIT. And they modeled the state of the planet, and they modeled the future. And they concluded that basically the whole thing was going to collapse because of lack of resources. But what was amazing is that they didn't really consider water and food as being factors that would turn out to be limiting. So the premise then in the 1960s and 70s was that the planet has a carrying capacity for human existence that cannot be exceeded. And the premise was abandoned in the 1980s by devotion to the continual rise of the gross domestic product. So that era of my formative years when we were worried about certain things, all those worries disappeared. Now, the key to a lot of this is this graph, so the 1960s there was when the exponential population growth began, and then after all these years of exponential growth, we're here there where it says now. And during that period of growth, at least recently, then the population expansion has been 80 million people a year. And we're going to keep adding 80 million people a year for a few more years. And then the experts on this tell us that it's all going to peak in about 2060. And the more you read about this, the more confident these predictions are. And after 2060 or so, then we're going to go into decline where the total world population is going to decrease, and that's what the economists are now worried about. So the good news here is this peak is only a few decades away, and we're only going to add another billion people or 1.5 billion. That's the good news. And we just have to get to that point then. Oops. So the challenge then is to get beyond peak population without civilization collapsing. So what is most threatening to humanity and the planet? Well, we've got different perspectives from credentialed high-profile individuals. Bill McKibben's written books. He appears, in the New York Times and all that stuff. And his thing is greenhouse gases and climate. And he's a journalist. And then we've got Johan Rockström, a professor at University of Stockholm. Very highly cited person. He's kind of a climatologist. And he's proposed that we have 9 planetary boundaries and that we can't overcome these boundaries or we'll be in bad shape. And then we've got Joel Byrne, who's written a wonderful book that I recommend to everybody that I'll mention here a bit more, and his focus is food. Oops. And then we've got Lester Brown, who I think is the most knowledgeable person of all when it comes to the state of the planet. He's now 88 years old, and we're trying to get a hold of him, but he was last heard of in 2015. And he used to report on the state of the planet every few years. And I remember reading his reports, etc., not thinking about them very much, but saying, oh, here's a guy who's interested in the state of the planet. So McKibben, then, here's a quote from him: "Climate change is the greatest challenge that humans have ever faced. And of course, this is played out in the media almost daily. And then we've got Rockstrom, who's in a Netflix movie. And usually when I give this lecture, I ask if there's anyone in the room that's seen the movie, and usually the answer is no. I think I've only found one person who's seen it, which shows how interested we geoscientists are in the state of the planet. So this movie is unusual. It's just based on a paper he published in 2009 in Nature. The paper was accepted by the editor without peer review. I think if it had been peer reviewed, it would have been rejected. But anyway, it's gone into the stratosphere in terms of being respected. So Rockstrom fears us hitting these tipping points, and the world must avoid them or we're going to have disaster. The word tipping point then is a word used in many different ways, mostly people who don't understand it, but the general purpose is to generate fear. So Rockstrom's paper was very important, and he's got these planetary boundaries, and the issue is which one is transgressed and which one is not. But the point here is that he didn't see water and food as being important at all, and what's interesting in this journey I'm taking to try to find out about the state of the planet is some people think water and food is basic to it all, and some people don't think it's important at all. So Rockstrom, okay. So then we've got Joel Byrne, who's a very well-known author now, and he works for National Geographic, and I communicate with him regularly. And this is his quote: "To feed the world with its ballooning population without destroying the planet's land and water is likely the greatest challenge that humanity has ever faced." Then we've got this person, Lester R. Brown, and he founded and directed the World Watch Institute in 1974, and then when he retired at the age of 80 or so in 2015, it was folded up. And here are a couple of quotes from him. "The world has quietly transitioned into a situation where water, not land, has emerged as the principal constraint on expanding food supplies." Lester R. Brown, who was said to be, by the Washington Post, one of the world's most influential thinkers back in that era, "The real threat to our future is peak water. As population rises, overpumping means some nations have reached peak water, which threatens food supply." And Lester R. Brown, then, if you want to hear him speak, in 2013, there's a very nice YouTube lecture that you can look at. And the title of this lecture he gave at Harvard was "Peak Water, What Happens When the Wells Go Dry?" So why are there so many different opinions by credentialed individuals on the state of the future of the planet? And each one of these opinion areas I view as kind of an intellectual tribe. And each tribe has its own perspective. But let's get beyond the tribes for a moment. Let's look at what these bureaucracies think, and we're giving them some credit for thinking here. So the World Bank in 2015, water is reaching a tipping point. Again, this word tipping point. The U.S. National Intelligence Council, water insecurity is threatening world economic growth and political stability. The World Economic Forum, water insecurity risks triggering a global food crisis. So we got tipping point, insecurity, we got food crisis. They're all lined up here through the opinions of these bureaucracies. But in fact, these bureaucracies don't recognize groundwater as being part of the problem. That's the kind of amazing thing when you try and dig deep into what they actually are thinking. Now, this is the year of groundwater declared by the United Nations, and March 22nd was World Groundwater Day, so it's a big deal in these bureaucracies. And a very interesting report that everybody should look at was produced by UNESCO, written by a bunch of very competent people. Groundwater is central to the fight against poverty, to food and water security. And my comment here is, however, the fight has not yet begun, although the enemy is upon us. So the disappointing part of this report, representing what the United Nations think, is recognizing where groundwater is and where all the people is, but hardly any of the issues that I'm raising here were contained in this report. And that seems to be because that recognizing problems in detail and tying them to groundwater seems to be almost politically unacceptable. It's just too mysterious. So what is the state of humanity on the planet? And so my view here is from the groundwater tribe. So I'm representing all of us here in the room in this tribal context. So if you don't think I've got it quite right at the end of this lecture, please let me know so I don't go on embarrassing us all in the world. So groundwater is everywhere beneath us, and we groundwater people know that. You know, just about anywhere beneath us, in the cracks in the rock and the pore spaces, we've got fresh water. And in 2005, I was on a very interesting field trip in China out on the Gobi Desert. So we drove for hours and hours out in the Gobi Desert where you don't see sand dunes. All you see is wind-swept landscape. And we were going there to see a site that the Chinese Nuclear Agency is going to use to develop their deep geological repository. And we're driving along, and then I'm seeing something that looks interesting. And so we got out of our vehicles, and what did we see was a well, a hand-dug well, like in the middle of the desert, where there's hardly any rainfall at all. And you look down, and there's the water level, like it's only a couple of meters down. It's fresh water, etc. So what's that doing there? It's because the nomads have been traveling across this desert for centuries, millennia, with their camels, and they don't travel now with camels. They travel with little tractors, and they have their yurts. So what are they doing there? Well, they got their sheep and their goats, and every once in a while when it rains, there's a little bit of green stuff, and I guess that's enough to make it all work. The point being that there was fresh groundwater there, much to the surprise of the Nuclear Agency. And what's the fresh groundwater doing? It's traveling along in the cracks, etc. So when we pump groundwater, we create a drawdown cone that almost everybody in this room knows. And we're drawing the water, and that's no problem. And if we keep pumping, then the drawdown cone might go out to some surface water, it might go out to the stream or wetlands and whatnot, and draw water in from the surface water system. And that's no problem if we don't pump too much. But if we keep pumping a lot, etc., we can start dewatering the stream, and then the water we're getting out of the well is basically water taken from the ecological system. And so one of the big problems now is there's so much groundwater pumping around the world that ecological systems are starting to suffer. And there are maps of the largest aquifers in the world, and this shows one of them. And these large aquifers that are known and mapped then provide apparently 40% of all of the groundwater extracted. However, 1/3 of these large aquifers are said to be depleted beyond recovery in human time. So that means then that we pumped out over decades much more water than is recharged from rainfall, and we're basically mining these aquifers for all practical purposes. And there's this huge aquifer in the United States, the Ogallala Aquifer, and this is a book written about that aquifer by an anthropology professor who's at a university in that part of the world. The imminent depletion of Ogallala and other aquifers around the world is our defining planetary crisis of our time. So these opinions aren't just coming from groundwater people, they're coming from others who look into the situation. And this is the Ogallala Aquifer, going all the way from South Dakota to Texas, and it's used for irrigation. And all that got going in the 50s when big pumps and electricity became available everywhere. And basically, irrigation is going to continue until the aquifer is drained, and then it'll have to stop. So there's no impediments to continue to drain the aquifer because there's money to be made, and that's the way groundwater development works, as far as I know. Okay, from science, overpumping for food production, massive losses of groundwater from the aquifer underlying California's agriculturally important Central Valley have occurred since the 1980s. And if you pay attention to where your food is coming from when you go to the grocery store, of course, you'll see that much of it's coming from California, and much of it's coming then from groundwater that's not sustainable. But let's look to where the problems are really serious. India. India has 1.4 billion people. That's the same population as China. About 300 million more to be added. India, 1/5 of the global population, but only 4% of global water. India, the world's largest groundwater extractor, 92% for agriculture. 2/3 of the population depends on agriculture for their living. And tens of millions of farmers have water insecurity. 6,000 farmers die from suicide a year in India, apparently, because their situation is so dire financially, they'd rather leave this world. Too many wells, too much pumping, not enough groundwater. And how did all this happen? It happened from inappropriate government subsidies. So the farmers got the wells subsidized, and then they got the electricity subsidized, and then the aquifers are drained, and that brings it all to a disastrous end. Disaster now happening in Iran. Groundwater decline due to extensive overexploitation of groundwater, and rising salinity levels points to dire, worsening water security risks across the continent. Iran is facing a state of water bankruptcy, and this was published just a year or two ago in a very reputable journal by some excellent Iranian hydrogeologists. Okay, so we've got highly publicized recent droughts, and I was in Cape Town at a conference in 2017, and that's when they were just about ready to turn off the taps. It was this huge thing, and you've all read about it around the world. And that was not a real drought. It was only a 2 or 3 year drought, and it was basically a political drought. And then there was the drought in Sao Paulo, which was only 2 years long, okay? And these caused great political crises in terms of urban water supply. And then the California drought of 2011, 2015. So these are just mini droughts. They shouldn't be causing a problem at all. They only caused a problem because of water mismanagement. And the mega droughts are the one that really caused the big problems. So now we've got drought in North and Central America, likely to start a mega drought. Oops, what am I doing here? And in the U.S., thought to be a mega drought starting, etc. It's been lasting now for a few years. And then the reservoirs go dry, and this reservoir has then gone dry, and the boats have all been removed. The new normal, Europe is being hit by a drought crisis. Okay, so droughts are occurring now in various parts of the world at the same time. Most severe drought grips France as an extreme heat persists in Europe, and the French Prime Minister says this drought is the most severe recorded in our country, and that's wrong. Okay, if you're going to talk about droughts over time, you have to look at the paleoclimate record, not just the newspaper record. And groundwater is commonly the only source of fresh water during drought, and so as a humanity, we don't seem to register this. Like droughts come and go, and they have done so for hundreds and thousands of years, etc. Okay, and at the present time, then, these major rivers are running dry, partly because of too much water use and irrigation and all that stuff, and partly because the weather's been a little bit dry for the last few years. Rivers totally going dry, with no water reaching the ocean in the Yellow River in China, which is amazing. So from a geological perspective, the climate is always changing. Okay, we have climate variability. The Arctic had no ice 8,000 years ago. It was warm up there, all the ice was gone, etc. And between 1570 and 1680, there was a little ice age in Europe, so cold that people couldn't grow crops and half the people died. So basically, changing climate and people dying and droughts and all that stuff is part of the paleo record. So drought is a meaningful term. Climate change is no longer meaningful. It's been confused and abused by media and politicians so that when we hear it, you probably shouldn't even pay attention to it. Try and figure out what it's all about. Now, this is the only slide here from actual research that I've been involved in. A few years ago, we published a paper on the paleoclimate in Southern California based on some work we were doing at a site north of LA. And the only thing in this graph that's relevant is that the blue is periods when there's rainfall, and the yellow is periods when there's drought. So when you take our records and you take the records from trees and other things, you see that there's some, in the past, over the past 500 years in Southern California, there have been quite a number of mega droughts. And a mega drought then is a drought that's anywhere, from 5 to 20 years long. Now, drought helped cause serious war. There's lots of papers on this when you start digging, and will climate change bring more like it? But the thing about Syria, when you look into it, is then the population from 1950 to 2010 went from 2 million to 22 million. So there are countries that grew their population enormously when there was reasonable weather, and now they're caught in the drought crisis. So the Syrian war, lack of water, was a trigger, okay, and you have to kind of dig around to find out this type of statement. 75% of Syria's farms failed, 86% of the livestock died between 2006 and 2011. And water and food, almost non-existent, social upheaval and uprising followed and fueled the civil war, where 80,000 people died and millions migrated. So groundwater scarcity and conflict is happening all over the world, and here's a title, Managing the Hotspots. And water then drives refugees into refugee camps. And one of the problems with refugee camps apparently is a lack of water, and the only possible source of water will be well water. But in many cases, the wells aren't happening because there's not enough hydrogeological expertise to make it happen properly. There are 468 transboundary aquifers identified in the world. A transboundary aquifer is then an aquifer that goes from one country to the next. And there are very few agreements between the countries on what will happen when they all need the water. And so this is another potential source of conflict. So this is my slide, blueprint for human suffering and civilization collapse. So on the upper left, we've got soil loss and erosion, salinization, etc. And we've got excessive groundwater extraction. And then if drought comes along, then we've got a problem. We've got farmer and food insecurity, social instability, and then, as I've indicated, we've got migration, refugees, and armed conflict. All of this is now happening. The evidence for this is clear of the last 10 or so years. So this is the way the world is transforming. And then in addition, because we're still adding people, we've got a declining per capita availability of water. Running out of water as the population increases was off of some article, etc. And so we got some conflict, we got some concepts here. These are very, very important concepts. Introduced into the scientific literature in 2010 by a scientist in California by the name of Peter Glick. And he said there's peak water, and we likely are at peak water now. There's peak sustainable water, okay, and we passed that long ago. Everybody agrees to that. And we got peak ecological water, and we passed that long ago. So by this overpumping of groundwater and using too much groundwater for irrigation and all of that, we're doing a lot of harm to the planet. So let's look at this a little bit more closely. Let's take one of these big aquifers in northern Africa that underlies 3 or 4 countries. And these countries have 85 million people that rely on this aquifer. And almost all the water pumped from it is fossil water. So it's water that has geological age. And let's take Saudi Arabia, for example, where they're totally dependent on fossil water. And they've been doing a lot of irrigation. It's kind of coming to an end. So fossil water are supplying hundreds of millions of people globally. And if we look at Saudi Arabia, then this water is 30,000 years old, and it was recharged to the aquifers then when the climate was much more wet back then. So it's like oil, just pumping it out and mining it. Whoops. Okay. So this is an interesting graph. This is for Saudi Arabia, and Saudi Arabia then passed peak water. And this is a pretty clear use of the word peak water. It's just like an oil reservoir. So Saudi Arabia can only exist based on importing food. So as long as the rest of the world is able to send food to Saudi Arabia, they can exist, and as long as Saudi Arabia has enough money to pay for it. So this graph I pulled off the internet a while ago, and it's a plot of global freshwater use over the long run. I don't know where these numbers come from. I didn't dig deep for that. But basically, if you take the graph at face value, total global water use has plateaued, though the water demand continues to rise. So it would seem that we're at some serious point of peak global water because there's a greater and greater demand for water, and there's not more water being produced by the system. So I took that graph and replotted it, and then Glick has a graph on the U.S. So the U.S. water use isn't going up, even though the industrial output is going up, and even though the population is going up, because they're making more efficient use of the water. So the U.S. passed peak water a few decades ago, and they now manage to exist on what they've got. So humanity basically is wrongly distributed across the planet when it comes from the point of view of water and growing food. 30% of the world's population lives in deserts and drylands, and 44% of all cultivated land is in drylands. Groundwater and food facts. So 40% of global agriculture is by irrigation, 70% of irrigation water is groundwater. But that number is usually reported at 40%. But you got to take the amount that's coming out of wells, and then you have to take the amount of water that's coming out of river base flow, which is groundwater. And if you add those two together, then it's 70%, which is a number that you don't see except in 1 or 2 places. And then we have to keep in mind that during long drought, nearly all food is from groundwater. And this graph shows then the groundwater irrigation for many important countries, India, China, USA, etc. And the black is basically irrigation water from groundwater. And what we see here is that most food growing in these countries then is dependent upon pumping aquifers. So then we have the concept of virtual water invented by Anthony Allen, a deceased professor at a university in London. And virtual water means then that when you look at food, you should contemplate that it's got water to produce it. So we've got virtual water being shipped around the planet. And if we're eating beef and whatnot, then we've got lots of water in our food. And if we're eating lower in the food chain, then we've got very little. And so people have studied this. Engineers in Holland have done these calculations and whatnot, and they keep track. And so virtual water is just being shipped around the world every day from one country to another, etc. So virtual water enables people to live where enough food cannot be grown, and it leads to food insecurity. So Canada's become food insecure because now we don't grow very much of what we eat. We grow grain and we export it out, and we eat food mostly from California. And of course, when I was growing up, most of what I ate was locally grown. And then a few months ago in a grocery store in rural Nova Scotia, I was looking at this asparagus, and I'm wondering, how did we get asparagus here at this time of the year? And it came from Peru. Interesting. But then the question is, when we look at food these days, we should always ask the question, is it sustainable food? And then I just happened to find this article. This article focuses on Peru, where agricultural export production has led to huge economic growth and employment, but at the expense of unsustainable aquifer depletion. So that food's going to come to an end because they're pumping unsustainable groundwater, and likely there's going to be a lot of human suffering as that comes to an end. Now, we have great differences in agricultural practices. We've got restorative agriculture, which doesn't ruin everything, and then we've got modern agriculture, which basically mines the soil. It releases the carbon to the atmosphere to cause greenhouse gases, etc. Now, not only is the area of productive soil declining, but the nutrition level of food from soil is also declining. And here's a paper from the most eminent expert on this topic. Soil degradation affects human nutrition and health malnutrition and hidden hunger that affects 3.7 billion people. In 1945, the United Nations declared that the entire world could collectively suffer from a food crisis. So the Green Revolution in agricultural technology began and was given this title, Green Revolution. Sounds good. And then the Green Revolution, then, which lasted from 1950 to 1980, it involved the improvement of crops, high-yielding varieties of cereals, and that was a good idea, and wheat and rice. All that was very, very important. But then added to it was large equipment, chemical fertilizers, pesticides, and that made the Green Revolution appear very successful. But really what made the Green Revolution appear successful was irrigation, which you almost never hear mentioned. So the Green Revolution appeared to be the savior of humanity, but it's founded on unsustainable groundwater irrigation. Now, irrigation, the way we do it, which is done so irresponsibly then, causes soil salinization, and that causes loss of soil. And so the soil that's useful for agriculture then is diminishing over time due to erosion, salinization, and loss of carbon matter. Now, irrigation by depleting aquifers has enabled the Green Revolution to appear sustainable until recently. And groundwater is unseen, and the wells are unseen and mostly unmonitored. So people don't connect all of this to groundwater in general. So as a sustainable solution to global food, this revolution was a mirage, and it sort of delayed the recognition of what humans need to do on the planet for a few decades. Limits to growth. Let's go back to this. They didn't consider food and water. Like, how could they possibly miss that? And I think they missed it because everybody believed that the Green Revolution solved the problem of food production forevermore for humanity because it was just so astoundingly productive. Depletion and mismanagement, well, we've got soil salinization and we've got land subsidence, etc. So let's look at land subsidence. Now, if you're like me and you would be reading the newspapers, you would be thinking that as the climate heats up, one of the big problems facing humanity is going to be basically sea level rise. And you see all these articles on people on our little islands and having to move. So what's that all about? And each time the IPCC or whatever issues a report, the amount of sea level rise diminishes. And so basically the sea level used to be rising at about 1 millimeter per year, and then more recently it's been rising at 3 millimeters per year, so that's 20-some millimeters in the last few decades. And what's causing the rise? Okay, well, we all heard about melting glaciers, okay, and then the physicists calculate water expansion, and what you don't hear about is groundwater, because these papers, they're published and whatnot, and they're never incorporated into the IPCC reports. All right, so there are 500 million people around the world, or whatever, who have good reason to fear sea level rise, but it's relative sea level rise. Okay, in other words, their cities are being encroached with seawater, and that's because the land is subsiding. It's not because of glaciers melting. Land is subsiding because we're overpumping the aquifers, and the land subsides when you decrease the pressure and the clay beds compact. Okay, so this whole story about the fate of humanity is dependent on graphs. Okay, and this is a very important graph that nobody would ever see because it's buried in a thing produced by the International Association of Hydrogeologists, and people are probably not going to read that. So this is a graph of depletion in kilometers cubed of volume versus time. And it shows that it's going up exponentially during the last few decades, and it shows huge air bars on it. And the air bars are probably even a lot larger. Like, how do we know how much groundwater is being depleted, etc.? So this is a very important graph because it brings groundwater into the picture in terms of a resource. All right. So then I've taken that other graph of total water use, and I put this depletion graph on the same page. And here we have the crux of the problem. So if you're going to remember anything from this lecture at all, it's this slide that's most important. So we're at peak water, and that just means people aren't able to pump more water. But at the same time, we're allowing ourselves to stay at peak water by depleting aquifers. So that's obviously unsustainable and has to come to an end. So we're on a disastrous freshwater trajectory for humanity. And we see these projections. Projected groundwater use increase 30% by 2050, and that's UNESCO. And what's disturbing about these projections is they're impossible. So the point should be that we have this huge water demand, and how are we going to meet the demand? We're not going to meet it by just producing more water. Okay, let's change gears here. So we've got 8 billion people on the planet, and we've got 3.2 that are rural by a definition. So we have a paradox. So we have groundwater that's over-extracted, mismanaged, and abused. And so for that, we need to have less pumping. And then we've got groundwater that's under-extracted, not accessed sufficiently to solve the global water problem. So to solve the global water poverty problem, we need more wells to serve at least 1 billion people. These are both groundwater problems, but they require very different solutions. So the largest and most shameful failure of our society, it's my proposal, is that more than 2 billion people have no access to safe drinking water in 1975. Okay, we've known this for a long time. And the numbers increased with population growth, and now a minimal estimate is that 1/3 of humanity is in water poverty. What's that mean? Water poverty, by definition, by the UN, means either you have to walk for your water, and that's a major part of the day's family's job, mostly by women and children, or when you get to your water, the water is contaminated with bacteria and viruses so that it shortens your lifespan and makes everybody sick. So that's water poverty. And here's a slide taken by a colleague in Kenya. Water washes away poverty. And what the big agencies in the world that are supposed to be solving the poverty problem in the world don't seem to focus on is the fact that you can't solve the poverty problem unless you solve the water poverty problem. Now, these people in water poverty, many of them are up in the mountains, and we have 1 billion people in the world that are living up in the mountains, etc., many of them in poverty. And so how come they're living in the mountains? Like, how can they be there? Well, they're there growing their food. They're there growing enough rice and whatnot to survive. But the only way they can be there is if they've got water from springs and seeps, because you can't be up in the mountains living unless you've got a continual source of water. And so here we have a hydrogeological diagram of a mountain, which I'm told is a silly conceptualization, but for this purpose I think it's good enough. And so when you go up in these mountains and you're looking at where the people are and you wonder why they're living there, you go finding their springs and seeps and whatnot. And mountains are made of rock, otherwise they wouldn't be mountains, and so it's basically fractured rock flow. And I'm on a trip here in China, I don't know, maybe 12 years ago, up in the mountains to look at the state of affairs in the company of an American environmental engineer who's been looking at this problem for quite some time as an engineer, as an NGO. And these are some of the poor-looking springs where people get their water. And then the government provides incentives and money and teams to come in and make the springs look better. Okay, you make the springs look better, the people can get the water more easily, but it doesn't change the fact that they're heavily contaminated with bacteria and viruses, because the bacteria get from the latrines and the animals and whatnot into the shallow subsurface. So these are water supplies that the United Nations then classifies as improved. And improved, according to the classification, doesn't mean that they're safe. So there's been very little progress on safe water supplies. And they're unsafe because of E. coli indicators, et cetera. And there's lots of data on this. So the current state of the planet, all our factors, freshwater, soil, oceans, forests, and climate, they're all deteriorating, and we need these to be improved for survival. So there's this book that was quite famous back a number of time ago by a very famous professor at UCLA, Collapse, How Societies Choose to Fail or Survive. Factors that precipitate societal collapse and environmental damage like deforestation, pollution, soil depletion, erosion, etc., and conflict. Okay, so the planet has a carrying capacity for human existence that we mentioned, and we've exceeded the carrying capacity by basically our bad decision making, and we need to do some fixing. So under my definition of collapse, then, those living in affluence will shrink while the rest of humanity expands until the remaining affluent are in enclaves surrounded by the vast majority in extreme poverty, famine, ravaged landscapes, migrations, and social conflict. So this is the scenario. It's not only mine. There are other much more eminent people than me writing these type of things. So unless we make drastic major changes in how we function on the planet, this is the way it's going to unfold. So I have our paradox. Groundwater is over-extracted, and we've got to get that under control, and then we've got to have more wells for those people that need it. So water poverty was eradicated from America by self-supply that started locally with low-cost methods used by the local people. So the experts on this topic, when we ask the question, how are we going to get millions and millions of wells to poor rural people, it's got to be done the way it was done, in America and Canada 200 years ago. And so is this feasible? Well, there's groundwater everywhere, more or less. And back in America, then, people had hand pumps. Okay? That's hand pumps for very small wells. They weren't draining the aquifers. They were just getting enough water to live. And how did they get their water? Well, they dug for it, which is what they do in the developing world. Or they developed very simple non-gasoline-driven machines so they could do well drilling by manual means. And 45 million hand pumps were sold back in that era, and then the hand pumps went with these wells that were drilled in very simple ways. So a third of humanity is in water poverty, but it only takes 500 liters per family to lift a family out of water poverty. So they don't need much water. You don't have to drill a big well, etc., to satisfy the needs of the water poverty. Back in Wisconsin, and in 1985, this is a manual drilling machine where they had horses and men working. In Bolivia, a more modern method was developed by a German engineer in 2011. It's been used now all over the world. And this leads to hand pumps, like very simple hand pumps that don't cost much, and they can be connected to solar panels as an improvement, but nevertheless, the key is to have the hand pump in the water. And so how can this be done? Well, the experts on this say it can be done mostly by manual drilling. And on the right, we have this machine that I mentioned from Bolivia, and on the left we have a much more modern manual drilling machine developed by an engineering school in Utah. So there are various ways of making a hole in the ground so you can get out 500 liters a day. Or there are drill rigs specifically developed for developing countries that you would never use now because they don't work fast enough and they don't make wells that are deep enough and big enough, etc. But for developing countries, this technology is already there to use. Now, the definition of insanity is doing the same thing over and over and expecting different results. So why haven't we solved the global water poverty problem? It's because it seems we can't get into actually doing what needs to be done, even though there are very experienced expert people that are providing the chart, the path to do this. It's just a matter of money and belief. So there's no specific plan by the United Nations, the World Bank, the Gates Foundation, blah, 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 to basically solve this problem. And there needs to be a plan to do that, and I know of little NGOs that are working on a plan or trying to get attention to maybe implementing some of it. And so rural water poverty can be solved with simple machines in general, rainwater harvesting, and point-of-use water treatment. And these three in combination are a very powerful combination for getting people out of water poverty. Now, if we go back to the other problem, fixing agriculture is essential to fixing climate, ecology, and groundwater. And of course, agriculture uses more than 70% of our water, and it uses more than 80% of the planet's land. So obviously, everything roots back to agriculture. And we got modern agriculture, which basically drains the soil and produces a lot of food for a relatively short period of time and uses a lot of irrigation. And then we've got the ecological agriculture, of which there's many, many forms, and they're happening successfully in many parts of the world. But the thing about agriculture, the way it's done, is it releases greenhouse gases from the soil. And so if we're going to combat greenhouse gases, then we have to deal with the agricultural problem. So the path of success will be dealing with agriculture and water poverty. So modern agriculture then releases CO2 into the atmosphere, and restorative agriculture then takes CO2 out of the atmosphere back into the soil. So the most urgent action is fix agriculture, and for this there will need to be some on-average diet change. We don't all have to be vegan, but we need to make some changes in the wealthy countries so the people in the poorer countries can eat more meat, etc. And that'll be a big contributor to reducing greenhouse gases. Buying an electric car is no path to progress, although I have such a thing. Electric cars combat air pollution, and they're nice to drive and all that, but don't think they have anything to do with solving the bigger problems. So society, we're choosing to fail by erroneous and irresponsible policies, and we even subsidize doing ourselves in. 40% of the EU budget is for agricultural subsidies, mostly to subsidize unsustainable agriculture, and the same subsidies in the United States. These subsidies are doing huge harm. Going back to this book that I so much respect, it examines the potential of sustainable agriculture and provides a basis for optimism. So after this journey that I've traveled here to try and figure out what's going on, and I'm telling you today, I'm actually optimistic because the possibilities are much better than I thought they were, reading all the doom and gloom in the media. Here's a very interesting book that's mostly focused on nuclear energy, but if you really want to reduce greenhouse gases, then nuclear has to be an important part of the equation. Ontario is 60% nuclear, France is 75% nuclear, and China's building more nuclear reactors now than the rest of the world combined, because they've committed then to peak out on their greenhouse gases. So we've become anti-nuclear in our society, even though the Groundwater tribe, people that the Groundwater tribe that studies radioactive waste, and our message to the world is that you can safely bury radioactive waste in deep geological repositories. So when you ask people why they're anti-nuclear, they think it's unsafe. Well, there hasn't been a nuclear reactor from a modern reactor that's killed a bunch of people ever, compared to coal, where millions of people die a year. And the waste disposal problem has been solved in concept, but not politically. So a quote from Eldridge Cleaver, and none of you will know who he is. You had to be in the 60s, reading the newspapers and whatnot. So he was an African-American philosopher. If you're not part of the solution, you're part of the problem. And we have these important terms, so let's be aware of them. We've got climate change, climate variability, tipping point, peak water, water poverty, sea level rise, sustainable and civilization collapse. And these terms are almost always used by the media and the politicians in ways that are either wrong or misleading and for creating fear. So I think the only way to survive and get any perspective on anything is just basically don't read anything in the mainline media that has anything to do with climate change or the future of the planet. And you'll be much healthy mentally if you do that. And if you read that nonsense, then you're obligated to try and figure out which of it's right and which of it's wrong. So what should universities do? Well, universities should develop a multidisciplinary course on the state of the planet, and all the students should have to take it to graduate. So universities should do that so that you don't have to listen to me as a semi-amateur giving my view on the state of the planet. So there's the Groundwater Project, which I helped initiate a number of years ago. So if you want to know more about groundwater, go to the Groundwater Project. We have 30 books on our website, very well done by experts around the world. We've got 200 more books coming. And in a few years, anything that anyone would want to know about groundwater, hopefully we'll have covered with people that know what they're talking about. And also, of course, we're always happy with donations. And that's my end of my talk, so thank you for listening to this sort of personal view of the state of the planet, and I hope you don't find it too depressing, because in fact, it's meant to be optimistic. Thanks for your attention.
So John's agreed to take some questions, and I'm going to invite Tammy Middleton to come up and run our Q&A for us, Senior Hydrogeologist at the Region of Waterloo. Tammy.
So I'm told we have about 10 minutes for questions, and we would like people to come to the mic if possible, and if not, the mic will come to you. So, Michael, why don't we start with you?
And I would welcome being told where I'm wrong, or where I'm off track, etc. All that'll be fine for this type of lecture. When you're lecturing on data that you've gathered in your normal scientific talk, you don't want to be told you're wrong or confused. But for this talk, it'll be welcomed.
Yeah, my question, what are your thoughts on, take off from the question you had for university students, having education, like a course for it. What are your thoughts on getting the word out, the public awareness education for people in developing nations? Because you mentioned, as we know, the population growth, the boom, a lot of that is, and the vast majority of it is in developing nations, and people there still have the mentality that, for example, babies come from the stork, or having 10 or 12 children is insurance against, for someone to take care of you as you get older. What are your thoughts on getting the idea out there that, all the environmental issues, including all what you covered here, obviously would have to be in a simplified form, but how to get the word out there? Because you get lots of people having huge families and they don't understand what the consequences are.
So the population graph, as I mentioned, is really under control. And the birth rates are going down almost all over. And there's all sorts of organizations then working on that. And with education comes a decline in birth rate. But in terms of the water problem and all of that, then there's great need for videos and cartoons and children's books and all the things that we're not providing for people to understand groundwater. And groundwater's kind of hard to understand because you've got to kind of imagine it. And so there are NGOs working on that, and the Groundwater Project now, we're going far out of our way to find those organizations in the world that are interested in that so that we can be a base for it. And I might mention that the book, Wally and Deanna's Groundwater Adventure, that was produced here in Waterloo 30-some years ago, and it was a big local hit. It's been re-erected, and it's on our website, and it is soon to be the most read groundwater book by far in the world, coming out of Waterloo. And it's being translated into 27 different languages. Okay, and I'd forgotten all about it, and one of my colleagues said, John, why don't we find that old marvelous book? And we tracked it down and got permission to do it, and the authors of that book are still around, etc. And so that's like a start. And so so the Canadian government now, through its aid organizations, hardly does anything that I've been able to find that I would consider to be useful on the track we're talking about here. 30 years ago, that wasn't the case. There was CETA and IDRC. All that's kind of disappeared into other ways of taking our taxpayers' dollars and putting them into what's presumed to be aid for developing countries. So we as citizens and voters need to get onto that. We need to ask our political representatives, like, where's the money going? Is it going to do any good? And if it's not directed at water and food, then it's likely not doing what it should do.
Thanks a lot. Larry Swadek, Faculty of Environment. Nice to see you, Dr. Cherry. Comment that there's a saying that you should never waste a good drought, right? Because it's an opportunity to shift that political
Yep.
position somehow. What do you think about California and the groundwater law that emerged out of the last round of drought? And what would you have hoped had happened differently, and what could other parts of the world learn from that and take that forward?
So, I spent a lot of time in California, and I did my degree there and sabbaticals there. So, California has laws about water that are so inappropriate for water management that there's no hope. Now, when they had that latest drought, that created such political furor then that California brought in some regulations that we could say were a step in the right direction. But when a big drought comes, the use of the water, the private ownership, and all the legal aspects that have to do with water use in California make California almost impossible to manage water in a modern way, because they're so hindered by their past. So the drought created a big deal, and it created new laws and it created new awareness. But whether or not that's enough, that's going to deal with the issue. And then you got the big competition in California between people in the cities and people in the countryside. And then, if push comes to shove, then maybe we Canadians aren't going to be sent food from California. They might get, shall we say, nationalistic on their source. So it's the other countries in the world that aren't encumbered by all sorts of legislation and whatnot that have a chance to start over. Like South Africa, for example, apparently has much more modern water regulations, etc. But at the end of the day, the most limiting factor at all for everything to do with groundwater is lack of monitoring. Like that graph on how much water we're using, it could be wrong by a factor of 5 or even 10. We don't monitor it. A Kitchener-Waterloo region, of course, is monitoring, and Guelph's monitoring. There's the odd, highlight in Canada, but in general, groundwater monitoring is really still in the dark ages.
Thank you. Thank you, John. I'm the other John Thompson. Your talk, frankly, was riveting. I don't have any other word for it. Now, I come from the other side of the fence, so to speak, and I was very interested to learn from your presentation that agriculture accounts for about 70% of the problem, if I got those numbers correct. And in your optimistic frame of mind, you posed a number of solutions, potential solutions, none of which seem to me to be particularly compelling in light of the nature of the problem. And so let me put this to you. I come from the world of biotechnology, and a lot of the effort in biotechnology now, and a lot of the deep thinking in biotechnology, is on trying to introduce into plants, which we eat, resistance to drought. In other words, create plants using modern biotechnology that have that are more water efficient. You need less water. So my question to you is, succinctly, do you think that's a feasible way to approach this? Should governments be spending money on developing drought-resistant plants using biotechnology?
So I'm glad you raised that question, John. So at the end of the day, at the end of the day, I think one of our big hopes is that we're a modern technological society, and we've kind of gotten into this mess by not using technology appropriately. And so you would think that a big emphasis on government would be for technologies to get us out of the mess. And there's food being grown now in a lab and whatnot that's imitation meat. And so the technology for plants, though, needs to be a technology that actually enhances the soil. So almost all the technologies developed in agriculture so far have been in the wrong direction. They work for a while, like the Green Revolution, but then you end up with a soil that's depleted. So what we need then is agriculture with the appropriate, plants going with it, that'll restore the soil. So I think the optimistic point of my lecture, at least in my discovery of this journey, is that we need to focus technology and on the soil, and if we do that right, we can combat climate change, and it's all part of sort of the same actions. And first of all, governments need to realize what the problem is. Okay, agriculture is a key, obviously, because it uses all the water, it uses all of the land. So how can it not be the key? And why is all the flooding and whatnot? Well, if you change the soil and you make the soil so it doesn't take up water and the water runs off, of course you're going to have flooding. And you can blame that on climate change or whatever. So all this blame of everything on climate change, whatever that means, is a way for us human beings basically to absolve ourselves of actually solving the problem. In a concrete way. Okay, we're going to buy an electric car or whatever, okay, but what about all the other things that have to be done, and they have to be done soon? So, you know, if I, you know, next time I give this lecture, I think I need to add something about technology at the end, because we need to focus on that. So as you can see, this lecture is an experiment. I did it for the first time a year and a half ago remotely at the University of Hong Kong. And then I travel along, and then I get good questions, and then I do reading to try and get it, you know, together in a real coherent way that needs to be optimistic and has solutions. Yeah, Tadesh.
John, thank you very much for a great lecture. But continuing along the same line as John was asking, in Sri Lanka in 2021 they mandated organic agriculture. So that's something that you're proposing, you know, making the soil, restore the soil. And that turned out to be a complete disaster. Ended up in hunger in the country and you know, conflict and everything. So what's your thoughts on this?
Okay, so that's a very good point. Okay, it's now become quite known that when the Western countries decide on some solution that we're then going to promote and impose on developing countries, almost invariably we do more harm than good. So this whole push to change agriculture, if we push it on the developing countries and limit their access to oil and gas, then that could be absolutely the worst effect. So we obviously we need to have policies that somehow are not going to do damage. Now, agricultural food, when you go into your grocery store and you buy something organic, what does that mean? It doesn't mean anything to do with water sustainability. It's got nothing to do with soil sustainability directly. It's just a label that indicates the food is likely not as damaging as the normal stuff. So what we need then as consumers, we need food that basically has a sustainability index or has a water index or something. So in my travels, I keep on asking people, do you know of a group that's trying to develop that index? And usually somebody suggests somebody, and I'm told that I should get a hold of a group in Spain. So we're so incompetent as a society that we're not even putting money into figuring out what the environmental footprint is for what we eat. Huh. I mean, that would be a real good thesis, or lots of theses, etc. So one of my conclusions is I spent like the last 20 or 30 years of my career studying things that are only secondarily relevant. Now, am I embarrassed? No, I'm not embarrassed. Groundwater contamination is important, and it brought in a lot of money, and a lot of students could do theses, and pursuit of intellectual activity is a positive thing. But universities need to organize themselves somehow to make sure they have enough professors who are actually studying what's relevant to the problems of humanity.
Thank you very much, Professor, for scaring the hell out of us. Can I ask two lame questions from a lay public?
Yeah.
Okay. Number one, you know that there's 97% at least of the water is salt water?
Yeah.
Right? And the fresh water is only 3%.
Yeah.
Why can't we mine from the sea? Why can't we desalinate?
Yeah. Okay.
And then bury the salt, like
Yeah.
you suggested, with nuclear waste?
Yeah.
Bury it.
Okay, so
That's lame question number one.
Okay.
Lame question number two is, we are so many of us, okay? If we all decide to do some recharging of the aquifers, what can we do? What are the ways that we can take? What are the methods that will help the recharging?
So
you talked a lot about being, depleted.
Yeah. So those are two very good questions. So let's deal with the desalination question. So Singapore, for example, that has 5 million people sitting on a little island, totally dependent on its own water. So they desalinate in a big way, and then they treat all their sewage so it's drinkable. So the problem with treating your sewage so it's drinkable and desalination is it's very expensive. It's very energy intensive. So the wealthy countries are going to survive all this stuff I'm talking about because they'll have enough money to desalinate and treat their sewage, etc. So the energy costs of that are just too large for it to be a solution that's beyond the 1% level. Now, the other issue then is what should we do as communities and individuals to conserve water? Well, in places like southern Ontario, we've got lots of water in general, and we're not depleting our aquifers, and in that sense then, in many cases, just letting our water run off is not all that bad. And in some cases, if we put too much of the water into the ground, the cities don't function well because the water table goes up and then people have their basements flooded. So the problem with water as a global crisis is that the people and the climate and the water are distributed wrongly. So it really doesn't matter a whole hell of a lot what we Canadians do with water. That's not going to do any good for Saudi Arabia or Mexico or whatnot. Oh, and by the way, Mexico has severe droughts and whatnot and so forth. And when you go to your grocery store, look at where your vegetables and your fruit are coming from. So the question then, I guess, is, well, what should we Canadians do? And the only thing that gets a Canadian excited about water is when there's some announcement that the Americans want to build a big pipeline or an aqueduct to take Canadian water south. I mean, over my 30 or 40 years of watching this, that's the only thing that gets Canadians excited about water, because our water would be very valuable in Southern California and Arizona. So it's a strange global problem where those of us in the wealthy countries need to figure out what to do that's not harmful to the climate and people in other countries. And right now, the food economy is doing a lot of harm to a lot of countries, harming people that have no idea what's going on. That's what we're doing. And we're doing it because we can't do better, because we don't have information to do better, etc. But it makes sense that if countries want to defend themselves and be more, shall we say, environmentally friendly, we should be focusing on local agriculture. And I mean, it seems to be such a no-brainer. Agriculture that you can see, that you know is safe, that's sustainable regardless of the droughts coming somewhere else. You would think that that would be priority number one.
So we're just about out of time, but why don't we have one question to wind it up?
Thank you, Professor Cherry, for the presentation. My name is Dustin Garrick. I'm based in the Faculty of the Environment. Last year, Johan Rockström and Mariana Mazzucato were appointed to co-chair the Global Commission on the Economics of Water. So Professor Rockström is starting to appreciate many of the messages that you've highlighted today. What would be your headline message to the Global Commission on the Economics of Water about the economics of groundwater and what the priorities should be?
Okay, so this is the most delicate question that I've been asked, for reasons that none of you will know. But I mentioned Johan Rockström and his planetary boundaries idea. And it happened in Nature in 2009 with a little paper that's 5 pages long, which is very clever. It's got very interesting diagrams, where Rockström and his long list of colleagues from the University of Stockholm basically said that if you want to look at the state of the planet, you have to look at these 9 boundaries. There's ecology, and there's climate, and there's nitrogen and phosphorus, et cetera, et cetera. And water was only one of the 9, and food wasn't part of it. And in fact, until this year, when Rockström had a colleague at the Swedish Water Week announced with great fanfare that they now have added water to a transgressed boundary. So the Rockström 9 boundaries thing is the type of thing that happens when academics get together and try and produce something that's intelligent, but in fact they're missing some disciplines that are critical. So universities are siloed the way they kind of have to be, and the global state of the global climate is so interdisciplinary. And if you proceed with a team that doesn't understand groundwater, then you're going to proceed with some bad ideas. So not only then does that whole 9 boundaries thing incorporated some bad ideas, but the IPCC group of people also doesn't have groundwater expertise. They can't even arrange their carbon budget so it makes any sense in terms of the geosciences. They get the seawater thing all out of proportion and don't even know that the land is subsiding, and that's what's going to affect things. So the problem we have, I think, in this day and age is how do you get a collection of people with the right expertise together to analyze a very important problem where you're not missing any links. That's the problem. So the link that almost always gets missed is the subsurface water link. First of all, there are very few, relatively speaking, competent hydrogeologists, et cetera. It's a small minority in universities, just that discipline. And it just is out of sight and out of mind. And of course, that's why we, groundwater people, need to speak out. And so how did I get these water prizes? Well, these agencies, I guess, figured at the end of the day that it'd be too embarrassing if at least they didn't give a prize every once in a while to a groundwater person. And then I would show up and I'm an embarrassment because they don't know what to do with me. Like, well, like he's got a water prize, but like, what did he do? And is groundwater important? So we're in this weird space. But the Rockstrom et al. 9 planetary boundaries space is doing a lot more harm than good. And you should all watch the Netflix movie to see what I'm talking about. And then you can send an email to tell me whether you think I'm off track. Thanks.
Okay, we'll end for now. All of you in the next generation of geoscientists coming up, if you're worried if there was anything to do, now you know that there's some things still left for us to do. And also that the experienced generation can keep guiding and giving us leadership. So John, thank you for continuing to give us the leadership. And we're so thankful for it. So I'll just let you know that there's a reception outside, and be sure to look for the food tables and help yourself to that. And please join us. And thanks again for joining us for the talk today.